Hello students. Now we begin Unit 1, Foundations of Deep Learning. And I want you to listen very carefully because these are the most important and most predicted questions for your semester examinations. I explain everything slowly, clearly, and with full excitement, just like a friendly lady teacher guiding you in class, so that even a 10-year-old learner understands with confidence. We start with the question, give correlation between artificial intelligence, machine learning, and deep learning and compare deep learning with machine learning. Artificial intelligence is the broad idea of making machines think and act like humans. Machine learning is a subset of artificial intelligence where machines learn from data instead of being explicitly programmed. Deep learning is a further subset of machine learning that uses deep neural networks with many layers to learn complex patterns from large amounts of data. When we compare deep learning with machine learning often needs manual feature selection and works well with smaller data, while deep learning automatically learns features and performs better with very large data sets, though it requires more computation and data. Now, let us move on to our next important topic, definition of deep learning. From this topic, we can expect questions such as, define deep learning, explain pros and cons of using deep learning. Deep learning is a learning approach inspired by the human brain, where artificial neural networks with multiple layers learn representations of data step by step. One major advantage of deep learning is its ability to handle complex problems like image recognition, speech processing, and language translation with very high accuracy. It also reduces the need for manual feature engineering. However, deep learning has disadvantages such as requiring large amounts of data, high computational power, and longer training time. It can also be difficult to interpret and debug. Now, let us move on to our next important topic, challenges of deep learning. From this topic, we can expect questions such as, what is deep learning, enlist and explain challenges of the deep learning. Deep learning faces several challenges that students must understand clearly. One challenge is the requirement of large labeled data sets, which are expensive and time-consuming to collect. Another challenge is high computational cost, as training deep networks requires powerful hardware. Overfitting is also a challenge when models learn noise instead of useful patterns. Lack of transparency makes it difficult to explain model decisions, which is critical in sensitive applications. Now, let us move on to our next important topic, supervised and unsupervised learning. From this topic, we can expect questions such as, compare supervised and unsupervised learning. Supervised learning uses labeled data where the correct output is already known, such as classifying emails as spam or not spam. Unsupervised learning uses unlabeled data and tries to find hidden patterns, such as grouping customers based on behavior. Supervised learning focuses on prediction accuracy, while unsupervised learning focuses on discovering structure in data. Both approaches play important roles in deep learning systems. Now, let us move on to our next important topic, bias-variance trade-off. From this topic, we can expect questions such as, write short note on bias-variance and trade-off. Bias refers to error caused by overly simple models that fail to capture patterns in data. Variance refers to error caused by overly complex models that learn noise instead of true patterns. The trade-off between bias and variance is about finding the right balance where the model is neither too simple nor too complex, resulting in good generalization on new data. Now, let us move on to our next important topic, underfitting and overfitting with regularization. From this topic, we can expect questions such as, write short note on under and overfitting regularization. Underfitting happens when a model is too simple and cannot learn the data properly. Overfitting happens when a model learns training data too well, including noise, and performs poorly on new data. Regularization techniques add constraints to the model to prevent overfitting by reducing complexity and improving generalization. Now, let us move on to our next important topic, representation learning in deep learning. From this topic, we can expect questions such as: explain how deep learning learns representations from data. Deep learning learns representations by transforming raw input data through multiple layers. Each layer learns more abstract features, starting from simple patterns like edges and gradually learning complex concepts like objects or meaning. This layered learning allows deep networks to understand data deeply without manual feature design. Now, let us move on to our next important topic: working of deep learning with figures. From this topic, we can expect questions such as: how deep learning works in 3 figures, explain with example. Deep learning works in stages where input data passes through an input layer, hidden layers, and an output layer. If I explain the figures in words, imagine raw data entering the first layer, features becoming clearer in hidden layers, and final predictions coming from the output layer. For example, in image recognition, pixels become edges, edges become shapes, and shapes become objects. Now, let us move on to our next important topic: architectural principles of deep networks. From this topic, we can expect questions such as: explain common architectural principles of deep network. Deep networks follow principles such as layer-wise learning, non-linear activation functions, and hierarchical feature extraction. They use multiple hidden layers to gradually build understanding and rely on optimization techniques to adjust weights efficiently. Now, let us move on to our next important topic: architecture design considerations. From this topic, we can expect questions such as: explain architecture design considerations in deep learning models. Designing deep learning models requires deciding the number of layers, number of neurons, type of activation functions, and regularization methods. These choices affect accuracy, training time, and generalization. Proper design balances performance and complexity. Now, let us move on to our next important topic: limitations of machine learning. From this topic, we can expect questions such as: explain various limitations of machine learning. Machine learning has limitations such as dependence on quality data, need for feature engineering, difficulty handling very complex patterns, and limited performance with small or noisy data. These limitations lead to the development of deep learning approaches. Now, let us move on to our next important topic: history and evolution of deep learning. From this topic, we can expect questions such as: explain the history and evolution of deep learning. Deep learning evolves from early neural network research inspired by the human brain. Initial models face limitations due to hardware constraints, but advances in computing power, data availability, and algorithms lead to the modern success of deep learning. Now, let us move on to our next important topic: advantages of deep learning. From this topic, we can expect questions such as: explain advantages of deep learning. Deep learning offers high accuracy, automatic feature extraction, scalability with data, and strong performance in complex tasks like vision and language processing. It outperforms traditional methods in many real-world problems. Now, let us move on to our next important topic: real-life applications of deep learning. From this topic, we can expect questions such as: enlist and explain any 4 real-life applications of deep learning. Deep learning is used in face recognition, speech assistance, medical diagnosis, autonomous vehicles, and recommendation systems. These applications improve efficiency, safety, and user experience. Now, let us move on to our next important topic: industrial tools for deep learning. From this topic, we can expect questions such as: enlist and explain any 4 popular industrial tools used for deep learning. Popular industrial tools support model building, training, and deployment. They provide libraries, frameworks, and utilities that simplify deep learning development and speed up experimentation. Now, let us move on to our next important topic: deep learning frameworks. From this topic, we can expect questions such as: explain the use of TensorFlow Keras PyTorch CAF and Shogun in deep learning. TensorFlow supports large-scale deep learning with strong production support. Keras provides an easy-to-use interface for rapid development. PyTorch offers flexibility and dynamic computation graphs. CAF is efficient for image-based tasks. Shogun supports machine learning and deep learning research. With this, students, we complete Unit 1. And if you revise these concepts carefully and confidently, you are fully prepared to perform excellently in your semester examinations.